Hi guys, I'm excited to get to teach you about multiplying and dividing in scientific notation. I think you'll notice that everything I'm going to be showing you will look very familiar. First, let's make sure you understand your goals today. You have to first take notes in your notebook, then complete your Khan Academy assignment. Then you have a game on Google Classroom, and finally, when you finish early, you need to start on weekly work week 11. Remember that the way to be successful using a video that I've created for you is to use the pause button when you need to slow things down. So let's first look at how to get your notes set up. To set up your notes, turn to the next free page in your notebook. It should be right after our cutout notes on scientific notation. Turn your paper to where you're looking at the landscape view and divide the page into 4 sections. In the upper left-hand corner, title it First Factor is Too Large. In the upper right-hand corner, First Factor is Too Small. In the lower left-hand corner, multiplying, and in the lower right hand corner dividing. The first thing we're going to look at is how to fix the first factor when it is too large. Let's pretend like we've just solved a problem in scientific notation and we get the answer 21.3 times 10 to the 4th. I can quickly see in that first factor that it is too large because if you remember, the rule is that factor has to be 1 or larger but also less than 10. It is 1 digit too large. If I were to move my decimal once to the left, then it would be 2.13, which would fit our rule. In order to move the digit 1 to the left, I'm going to have to adjust the power of 10 in order to keep the same value in my answer. Since I am 1 too large, I'm going to add 1 to the power of 10. When I do that, I'm now allowed to adjust my first factor, and then I will add those exponents. What I get is 2.13 times 10 to the 5th. Now what we're going to do is we're going to check to make sure that those two original numbers are equal. The 21.3 times 10 to the 4th would mean I would have to move this decimal once to the right to get behind the 3, and then 3 more times means I would add 3 more zeros to that number. Now let's look at the second one. 2.13 times 10 to the 5th. I would move that decimal twice to get behind the 3, but now I have 3 more movements, so I would add 3 more zeros. We can now see that the way that we added a power did fix this number to be in scientific notation, but the values did stay the same. Now let's look at how to fix the first factor when it is too small. Let's pretend we just solved a problem and we got 0.61 times 10 to the 4th. We can now look at our first factor and see that it's too small because it's smaller than 1. We can also notice that we have 1 digit too small. If I were to move that to the right one, then it would be 6.1, which would work. Since now I am 1 digit too small, in order to allow myself to fix it, I need to take 1 away from my power. When I do that, I can now rewrite it as 6.1 times 10 to the 3rd, since 4 minus 1 is 3. So to recap, when it is too large, you think how many digits too large is it, and you add that to your power. When it's too small, now you think how many digits too small is it, and you subtract those from your power. Now let's look how to multiply numbers that are in scientific notation. Some students like to try to put each number into standard notation and then multiply, and then put their answer back into scientific notation. But I'd like to warn you that if you do that, you're working way too hard. It's easier to keep the problems in scientific notation. Let's look at this problem. We're going to look at 3.1 times 10 to the third multiplied by 2.2 times 10 to the negative fifth. The first thing that we want to do is realize that in multiplication, order does not matter. So therefore, I'm going to rearrange this problem. I'm going to take the first factors of 3.1 and 2.2 and put them together to the left. And then I'm going to put my powers of 10 to the third and 10 to the negative fifth and put them together to the right. What I'm going to do is I'm going to solve the problem 3.1 times 2.2, and then the problem 10 to the third times 10 to the negative fifth. Remember, we've already learned how to do 10 to the third times 10 to the negative fifth. In multiplication with exponents, what we do is we add those powers. So now when I do my 3 times 2 times 2.2, I do that the same as I've always known how to multiply decimals, and I end up getting 6.82. When I add my powers, I get 10 to the negative second, and that is my answer. Now let's look at how to divide in scientific notation. Again, leaving the numbers in scientific notation will be much easier than trying to change them first. Let's look at the problem 8.6 times 10 to the second divided by 2 times 10 to the negative fourth. What I'm going to do is I'm going to take my first factors and I'm going to divide those like I always have been taught to. I'm just going to think 8.6 divided by 2. Then I'm going to take my powers of 10 and I'm going to divide those using my properties of exponents. But be very careful. You have to remember order matters in subtraction, so you must do the top exponent minus the bottom. You're going to realize you get 2 minus negative 4, which will be positive 6. So when I do my division with my first factors, I get 4.2. With my powers of 10, we have 10 to the 6. So that answer ends up 4.2 times 10 to the 6. I can already tell you all have the awesome factor. Now let's look at putting it all together. Let's look at another multiplication problem. 1.5 times 10 to the negative fifth multiplied by 9.4 times 10 to the negative third. First thing we're going to do is we're going to put our first factors together and then rearrange so that we have our powers of 10 together. The problem will become 1.5 times 9.4, and that's multiplied by 10 to the negative fifth times 10 to the negative third. When we do that, we end up getting 4.1 as our first factor, and when we add our exponents, we get negative 8 for our second factor. So now we have 4.1 times 10 to the negative 8, but we notice a problem. Our first factor is breaking the rule. It's too large by 1 digit. Therefore, we're going to add because it's too large by 1 digit to our exponent. When we do this final fix and we move our decimal, we end up getting 1.41 times 10 to the negative seventh.